find the arc length for the function y equals x to the fourth over 16 plus 1 over 2x squared for x between 1 and 2. And this right here is x squared. So first of all, let's start with our formula. We know that length equals from sum a to b, square root of dy dx squared plus 1, or you could say 1 plus dy dx squared, same thing, dx. All right. So first, let's find, what is our dy dx. Let me go ahead and rewrite this as, I'm going to go ahead and rewrite my function as y equals 1 over 16 x to the fourth plus 1/2 x to the negative 2. That just makes my life easier. Let me go to the next page. So dy dx equals 4 times 116 is 1/4 x to the third. Negative 2 times 1/2 is just minus 1 x to the negative 3. And so dy dx squared should equals 1/4 x cubed minus x to the minus third times 1/4 x cubed minus x to the negative 3. Okay. So that equals 1 over 16 x to the power of 6. And then I get negative 1/4, then I get another negative 1/4, and then I get x to the negative 6. Okay. So that is my dy dx quantity squared, and I'm interested to know what is 1 plus dy dx quantity squared. So if I add 1, I get 1 over 16, 1 over 16, x to the power of 6. Negative 1/4 and negative 1/4 is negative 1/2. Add 1 to it, I get plus 1/2. And then I have plus x to the minus 6. And notice that I can rewrite this in a perfect square form. So let me go to the next page and claim that dy dx quantity squared plus 1, or 1 plus dy dx quantity squared, doesn't matter, equals to 1/4 x cubed plus x to the negative 3 quantity squared. You may have to review your algebra for that, for this step. So now that I have that, I want to go ahead and do the integral. So the length is from 1 to 2 that was given to me, square root of 1/4 x cubed plus x to the minus 3 quantity squared, and there's this dx. Okay, so I can go ahead and cancel this with this, and I'm now, actually that makes it really easy. Now I have length equals from 1 to 2, 1/4 x cubed plus x to the minus 3, and here's a dx. Let's continue on next page. So L equals, if I add 1 to the 3, I get x to the 4th, and then multiply that by another 1/4. Here I had a 1/4. Let me show my step. And instead of dividing by 4, I'm going to multiply by 1/4. And then I have here I had x to the negative 3, add 1 to it, I have x to the -2, and dividing it by -2 or multiplying by -1/2, I get -1/2 x to the -2, and that is from 1 to 2. I think it's a little bit would be easier for me if I say this is the same as 1/4 and times 1/4 is 1/16, so -1/2 x to the second, because I have negative power in here, from 1 to 2. So length equals, I'm going to go ahead and first put in the 2, of course, so I get 16/16 minus 1/2 squared is 4 times 2 is 8. And then I have, when I put a 1 in there, I get 1/16 minus 1/2. Okay, so, oops, L equals, I have 16/16 is 1 minus 1/8. And then I have, I don't need the parentheses anymore. Then I have a minus 1/16, and negative times negative is positive 1/2. Okay, so these two put together, L equals 3/2. Then I have minus 1/16, 1/2. Okay, so I had 1 minus 1/8 minus 1/16 plus 1/2. Okay, 1 and 1/2 gave me 3/2, and I can rewrite this to, this is same as 2/16, so minus 3/16. Okay, I'm a little bit tired here, so L equals to, what is my LCD? I can write this as 3/2 minus 3. So if I multiply top and bottom by 8, I get 24/16 minus 3/16 equals 21/16. Okay, that was an example of finding an arc length using integrals. Thank you.